All right, we're going to go ahead and move on to part 2 of this video where we're going to do some work factoring trigonometric expressions and also simplifying trigonometric expressions. So when we look at the first example, it asks us to factor the expression 4 times the tangent squared of theta plus the tangent of theta minus 3. When you look at this trigonometric expression, it's actually a quadratic trigonometric expression. So all this is asking us to do essentially is just factor the quadratic. So if you look here when factoring this, the leading coefficient, so the coefficient of the squared term is not 1. So I like the technique of making an x to factor this, where the number that's going to go on top is the product of the leading coefficient and the constant term, which is negative 12. The number that's going to go on bottom is the coefficient of the linear term, which is the middle term, which is 1. And then we're looking for two numbers that multiply to give negative 12 and add to give 1. And those are 4 and negative 3. Okay, so when we factor this, our goal is to take that middle term and break it apart into two terms using these two numbers that we found here as the coefficients. Okay, so I can do that by taking tangent and rewriting it in terms of two terms as 4 tangent of theta minus 3 tangent of theta. Okay, and those two expressions there are equivalent. Okay, so once I've broken this quadratic up into 4 terms, I can go ahead and factor the result by grouping. So when I look at the first two terms, I can factor out 4 times the tangent of theta, which leaves me with the tangent of theta plus 1. And then I need to factor something out of the last two terms, which leaves me with the same resulting factor, the tangent of theta plus 1. So when I factor negative 3 out of the last two terms, that leaves me with the tangent of theta plus 1. Okay, so once we've factored, the factor that both expressions have in common is the tangent of theta plus 1. And then when we factor that out, that leaves us with 4 times the tangent of theta minus 3. Another option that you can use is if you don't feel comfortable factoring with like trigonometric expressions in there, you can do a u substitution where you let u equal tangent, and then you can rewrite this expression as 4u squared plus u minus 3. And then you would factor that in the same way. That would factor to u plus 1 using the same technique times 4u minus 3. And then the last thing you would do is go back and resubstitute tangent in the place of u. And that would give you the same factorized expression as the one that we came up with. Okay, when you look at example number 2, there are some similarities between this and the previous example. So again, we have a quadratic trigonometric expression, just like we did in example number 1, but we have a problem with number 2 in that our trig functions do not match. So when you look at the squared term, it is cosecant squared, and then like the linear term, the middle term is cotangent. Those two trig functions don't match, so I'm not able to factor that expression the way that it's written right now. The only way for me to be able to factor this expression is to get this expression written in terms of a single trig function, which means I either have to get the entire expression written in terms of cosecant or the entire expression written in terms of cotangent. Well, if I want to get the entire expression written in terms of cosecant, the good news is the first term, cosecant squared, is already written in terms of cosecant. The problem that I have is taking this middle term here, cotangent, and writing it in terms of cosecant. And that's going to be really difficult for me to do. Okay, so when you run into problems like this, it's actually easier to get the trig function written in terms of the middle term. So it's easier for me to get this trig function written in terms of the middle term cotangent, because when I look at cosecant squared, if I go back to the Pythagorean identities, we can say that cosecant squared is 1 plus cotangent squared. So when I replace that cosecant squared with 1 plus cotangent squared, now I have this entire expression written in terms of cotangent only, which is going to enable me to factor the expression. So when I combine the constant terms, we get cotangent squared minus cotangent, and then 1 minus 3 is -2. And that's a really easy expression for us to factor. That's going to factor to cotangent of x minus 2 times the cotangent of x plus 1. And that's going to be a really important technique for us whenever we get into section 10-3, whenever we're solving trigonometric equations. When we're solving trigonometric equations, like one of the types of trigonometric equations we're going to look at is a trig equation where one of the sides is factorable. So you'll have to be able to factor, just like we did with the first two examples, to go about finding the zeros of those trig expressions. Okay, last example we're going to look at, the directions ask us to simplify the expression. And I personally don't like doing examples like this. I prefer doing identities, and whenever I ask you guys to take an assessment on this, I don't think I'm going to put any questions on this that ask you to simplify, because I find it hard knowing when to stop when doing problems of this type. Okay, so let's simplify. We have the sine of t plus the cotangent of t times the cosine of t. Okay, so all I can do to really simplify this expression right now is I see that cotangent, we can rewrite cotangent as the cosine of t over the sine of t times the cosine of t. Okay, so when I look at this quantity on the right-hand side, I can go ahead and combine that into a single fraction by multiplying across. So cosine times cosine is cosine squared over sine. And then to that, we're going to add the sine of t. Okay, so again, I want to try to simplify this. So what I can do to simplify this now is I can go ahead and add the two fractions.